So in this set of problems, what we're going to do is graph a damped vibration curve for t between 0 and pi. And so we want to look at a couple different things. First of all, we've got 4 options, and notice that your x window is the same for each one. So we're going to graph it out between 0 and pi. And our increments are going to be pi's over 4. So this is 1 pi over 4, 2 pi's over 4, which is pi over 2, 3 pi's over 4, and 4 pi's over 4, which is a pi. Our y window is going to go from -1 to +1, and then you'll notice that they gave us some inclination of how to read this thing. So I don't know if you can tell very well, but these are colored ink. So I've got some reds, I've got some blues, and I got some black ink. And so what we're going to look at is graphing this damped vibration curve. And so I am going to separate this out. I'm going to graph cosine, okay? And I'm going to graph a positive e to the -2t over pi. And I'm going to graph a negative e to the -2t over pi. And then I'm going to graph the whole thing at once. Okay, so I'm going to actually end up graphing 4 things in my y equals. So this entire semester, essentially, you've been in degrees. You need to get your calculator back in radians first. So hit mode. I'm already in radians. And then let's go to the window, and we'll fix our window. So my my x min is going to be 0. My x max is going to be pi. Okay, and I want to be my scale to be in increments of pi over 4. I want my y min to be -1, my y max to be 1, and my scale to be 1. Okay, so now we need to enter this stuff. So this is, ignore that. So this is going to be the benefit of paying attention to what color you've got. With a color calculator, I can scroll over and I can highlight that box, hit enter, and I can change the colors. But instead of doing that, I'm just going to go ahead and pay attention to what they said. So they said that for blue, that my damped vibration curve is going to be the entire equation. So I'm going to enter this entire equation. So it's going to be e to the, and then I've got a -2x over pi. And remember, you do not need to worry about t's or anything like that. Your calculator doesn't care what variable it is as long as you are using the correct variable. So just because we're in terms of t does not mean that your calculator is not going to recognize x, is what I'm trying to say. All right, so the next part says I need to have the cosine of 2t. So I'm going to put the cosine of 2x. So my blue curve is going to be the entire thing. Okay, my red curve, I'm going to have 2 of them. I'm going to have the positive e to the is red, and the negative e to the is also red. So I'm going to have 2 red curves. So I'm going to do e to the -2x over, over pi. And then I'm going to make another red curve. I'm not going to bother changing y3 into red, because then I would just have to change this into black, and that's too much effort. So I'm going to highlight, and instead of magenta, I am looking for red. And there we go. So scroll down and hit OK. And so now I've got my other curve. So this is going to be the negative e to the, oh good heavens, negative e to the, and then -2x over pi. And then for this part, for the black curve, I just want to graph y equals cosine 2x. So I have the cosine of 2x. So notice that we took all the little bits and pieces. So I took this thing, plus and minus, which you'll see why in a second. And I took this thing, and then I put it all together. So when I look at this, as it graphs it out, the blue one is going to graph first, and it's going to be the actual graph of the function. The red one, the positive e curve, is going to graph next. Then it's going to graph cosine in black, and then it's going to graph the negative e curve last. It goes in order. So when I hit graph, so the first thing I see is the actual graph of the function. Be patient, it's working hard. And then the next thing I'm going to see is my positive e to the negative 2x over pi. And then I'm going to see the cosine of 2x. And now I'm going to see the negative e to the negative 2x over pi. So what we've done is you can see that we're using cosine as a point of reference, okay? So this kind of sort of mimics the cosine curve. And then these red curves are actually boundaries on the actual blue curve of the graph. So the blue curve is the actual graph, okay? But you'll notice that it's kind of sort of squishing it as we come out here because it is damped motion. So now all you have to do is look at which one it is, okay? So which one of these things is it? So we're going to look at this again. So I'm just going to talk you through how to set it up. So look at this one. We're going to go from 0 to pi over 2. And you are in increments of pi over 8. So here's 1 pi over 8, 2 pi's over 8, 3 pi's over 8, 4 pi's over 8. And then I'm going to go from negative 1 to positive 1 in increments of 1. But notice this time there's only one graph. So instead of graphing all the bits and pieces, you're just going to have to graph this whole thing as, oh, I just totally lied to you. No, there is. So we're going to graph this part, plus and minus. I don't know why I just said that. Okay, so your positive e is going to be the red curve on top. Your negative e will be the red curve on the bottom. And they just didn't graph cosine by itself. So you can go ahead and graph cosine by yourself if you want to, and then graph the entire thing together, and that's going to either be this curve, or this curve, or this curve, or this curve. Okay? So we know how to do that one. Well, now we want to change the vocabulary just a little bit, and it says use the method of adding y coordinates to graph the function. So I'm going to walk you through how to do it once, and then we're going to look at how to do it on the graph. Okay? So notice I've got addition subtraction going on. So what I'm going to do is look at this as two separate functions. So I've got 3x, and I've got negative cosine x, and then I'm going to put it all together. So looking at this, I have 3x, and then I have negative cosine x, and then I have the whole thing put together, which is 3x minus cosine x. And what we're going to do is just arbitrarily grab some nice, friendly little t values or x values and evaluate. And so what I'll end up doing is, let's just do one. I'm going to use 0. Okay, so evaluate your first function at 0, I get 0. Evaluate your second function at 0. So negative cosine of 0 is negative 1. Okay, and then put these together. So 0 minus 1 is negative 1, and that's your answer. Okay, so you actually just do this several times by hand, and you'll find that you have lots of points. So the point 0, comma negative 1 is on this graph. So it's just a different way to organize it. Now, if we're going to actually do this in the calculator, let's go back up here. Okay, so what I see is I'm going to go ahead and graph 3 different things. I'm going to graph 3x, I'm going to graph negative cosine x, and I'm going to graph 3x minus cosine x on the third line. So I just have to determine what my increments are. So my increments look like they're in terms of pi. So I'm going to go from negative pi to 0 to pi to 2 pi to 3 pi. So my increments are going to be in terms of pi. So I want my window to go from a negative pi to a positive 3 pi. Okay, and then what's my scale? My scale is actually in terms of pi over 2. So if you look closely, and it doesn't matter which one we focus on because they're all the same scale. This is going to be pi, so this is half of a pi. This is 2 pi's over 2, 3 pi's over 2, 4 pi's over 2. So your x scale is going to be pi over 2. So pi over 2. And then what's my y min? Well, it looks like my y min is about -9. Okay. My y max is 20. And then what are my increments? I'm going in 4s. Okay. So if my scale can be 4, actually, let's just change this to -8 just to make it a little bit easier. So my scales are in 4. So I'm going to go from -8 to -4 to 0, 4, 8, 12, 16, 20. Okay. And then go to your y equals. And let's graph this thing. So the first one says I'm going to graph a 3x. Okay. The second one, I'm going to graph a negative cosine x. And the third one, I'm going to put it all together. So 3x minus cosine x. And remember, you better be in radians. Okay. And I don't care about any of this. So now go back up here and I can hit graph. I said I can hit graph. All right, so what I have then is that's going to be 3x. Oh, look at that. Okay, that's going to be cosine x, negative. And then look at this pretty picture. That black thing that looks like it's spidering around is going to be 3x minus cosine x. Okay, so that black graph is the actual graph, but you're seeing how they're kind of sort of put together. So that means you can do those problems. So actually we're going to do one more. I'm just going to set it up with you because you're supposed to give me a formula. So notice first of all that you've got a 2x, a minus sine 2x. So graph the 2x, graph the negative sine 2x. Then on your third y, you need to put the entire thing together and just change your scale appropriately. Notice on this one, you only have to graph one of them. Okay, there's only one graph represented, so you just have to graph this as a whole. You don't have to graph the bits and pieces. So this next one, to finish out this video, is I'm just going to show you because you need to use your trig identities. And what I'm given is a product, and I'm supposed to rewrite this product using product to sum formulas so that I can write this as an addition subtraction problem. So I have f of x equals sine x times the sine of 3x. So f of x equals sine x times the sine of 3x. And I noticed right off I got an alpha and I got a beta. And looking at my trig identity sheet for my products to sums, I've got the sine of alpha times the sine of beta is going to be this over here. So I have 1/2 the cosine of alpha minus beta minus the cosine of alpha plus beta. Okay, and let's make this a little bit taller so you can see what's going on. And then I can simplify. So I'm going to change ink colors because that's a little bit light. All right. So I need to do direct substitution. So what I have is 1/2 times the cosine of my alpha is x minus 3x minus the cosine of x plus 3x. Okay, so simplify again. So I've got 1/2 the cosine of negative 2x minus the cosine of 4x. Okay, and one thing should be tickling your brain, and that's the fact that a cosine, my argument's negative. I can fix that. With a negative argument, cosine is even, which means regardless of what I put in for an angle measure, it's going to pop out the same ratio, and that ratio is going to be positive. So I can ignore this negative. So my new function is now the cosine of positive 2x minus the cosine of 4x. So now I have written this product as a sum or a difference. And so now you can graph it. So that's going to be your first answer. And then regardless of whether you enter this in your calculator or this in your calculator, they're equivalent. It's going to give you the same graph. I said graph. It's going to give you the same graph. Okay. So I will see you for the last few.